solve the equation in the real number system. Okay, so solve, wait, no, it's not a function, sorry, it's an equation. So we want to solve x to the fourth minus 12x squared minus 64 equals to 0. Well, now we are going to solve this equation in the real number system. What we are going to do is we're going to look at our options, and one of them is going to have a -4 and a 4. So you're going to take out your calculator and you're going to plug it into the function, your option. So -4 to the fourth power minus 12 times -4 squared minus 64, and it gave you a 0. So you know that -4 is a correct answer. Now let's check it for 4, for the positive 4. Just erase this negative sign, delete, and it gave you a 0. So you know that that's your answer. Just plug it into your x's. Now let's do another one. Find a bound. Find a bound on the real zeros of the polynomial function. So bounds. Let's see. Let's find the bound of f of x equals to x to the fifth minus 2x to the fourth plus 4x cubed plus 7x squared plus x minus 2. Bounds. The only thing that you want to do for bounds is look for the biggest coefficient that you see on your function, which in this case is a 7, and then you take it down, take its absolute value, and add a 1. So 7 plus 1 equals to 8. And that means that your bound is 8 and its opposite. So bounds are -8 and 8. Those are your bounds. If this was a -7, you would take it down. The -7 absolute value is always positive, so it turns into a positive, and you still get 7 plus 1 equals to 8, so -8 and 8. That is your bound. Okay, that will be those. That's the way you solve bound problems. Let's see. Now we have to use the intermediate value theorem to determine whether the polynomial function has a 0 on the given interval. Okay, now let's see. We are given f of x equals to 9x to the fourth minus 2x squared plus 6x minus 1. And our interval is 0 and 1. What you're going to do for this is you're just going to plug in the numbers on your interval on the x's right here. So f of 0 equals to 9 times 0 to the fourth minus 2 times 0 squared plus 6 times 0 minus 1, which is equal to 0, 0, 0, minus 1. Then you'll do the second one, which is your y, so your x and your y. So we'll do the y, which is 1. So f evaluated at 1 would be equal to 9 minus 2 plus 6 minus 1. That gives you 12. Now, what you want to see here is that your x has to be smaller than 0, and your y has to be, the result from your y has to be greater than 0. Okay? So if you have your x smaller than 0, which in this case we do, -1 is smaller than 0, and your y is greater than 0, yes, 12 is greater than 0, then there is a 0 in your interval. Okay? So your answer would be yes, there is a 0. Okay? You have to do nothing else. If you get this number smaller than 0 and this number smaller than 0, then there is no zeros. There are no zeros, okay? Now let's do another one. Okay. The problem says that information is given about a polynomial f of x whose coefficients are real numbers. Find the remaining zeros of f. Let's see. Degree, we're given degree 3. Zeros are -8 and 4 minus I. Okay? You know from your degree that you have 3 zeros, but you're only given 2, so you need to find the third zero. So the only thing that you're going to do is take the 0 with the I and flip the sign of the I. So you have -8, 4 minus I, and 4 plus I. Let's do another one of these. So degree 4. Degree 4. Zeros are I and 6 plus I. Now, know that we just flip the signs, right? So we know that we have 4 zeros and we're given 2. But here's our third zero, -1. And our fourth zero, 6 minus I. Negative I. I'm sorry. And 6 minus I. That's it.